Hey guys, how we doing?
Hi, kids.
Section 7.4 here.
Special triangles. This is a big one.
Yeah.
You know,
Now they're not special because they're
no,
no, they're special because they show up a lot, right?
that's
So
right.
those
That's
referred to,
right.
yeah,
That's right.
special
There's going to be a lot of information here, guys, but we're going to spend a lot of time in class developing this too. So if there's a day to watch the video, it's this one.
Yep, important. Yeah, yep.
So, anyways, let's get rolling on this. There's two types we're going to look at today, and the first one here is a 45, 45, 90 triangle theorem. And when it says 45, 45, 90, we're talking about the angle measures, guys. So we've got two angles that are 45 and then the 90-degree angle. So we're talking more about right triangles. Don't forget that. This only works for right triangles. So, here we go. So basically a 45, 45, 90 triangle is it's when the hypotenuse equals the leg times the square root of 2. Now notice there's two legs on a right triangle, but it's only bringing in one. Okay, so it's the hypotenuse equals one of the legs times root 2, and you'll see why that is here in a moment. But basically, if the angle is 45, we label the side across from that A. If the other angle is 45, we also label the side across from that A, and then at the 90-degree angle, we call that A root 2. Now, I want you to make a connection here. If the side across from 45 is A and the other side across from 45 is also A, what can we make a connection about those two sides, guys? Hopefully you're saying, they're the same, Mr. Badella. That's right. Okay, the two sides across from the 45-degree angle are the same, and the hypotenuse is one of those sides, root 2. Okay, or one of those legs, root 2. So if it looks like this, all right, here's a good example of a 45, 45, 90. You see that the two angles down at the bottom, the base angles, are 45-degree angles. And now we have those two A's there. And then right across, directly down from the right angle, it's pointing at it, is the hypotenuse, and that is A root 2. Now you should also start to see here, guys, that a 45, 45, 90 triangle is an isosceles triangle. Therefore, that's why those two base angles are 45, okay? And that's why those two sides are both A's, because it's isosceles, so those two sides have got to be the same.
Right. Isosceles right triangle. 45, 45 is an isosceles right triangle.
Yeah, so I mean, that's the nice thing about it. If you see an isosceles right triangle, you know it's going to be potentially the 45, 45, 90. I mean, that's just kind of the way it is.
That's what it is.
Okay, so let's try some of this now. So if I tell you that that side is 10, then you got to know that the other side is also 10. All right, because A is the same as A. Now, this is the really hard part, so make sure you pay attention. You take the A out and you put the 10 in, and the answer for the hypotenuse is 10 root 2.
Right.
I mean, that's all it is, guys. It's just one of those legs times root 2. So you just take the side and plug it in, make it bump up right next to the root 2, and you call it a day,
Yeah.
basically is what it is, at the easiest point.
Whatever the leg is, you multiply by radical 2. That's how you get the hypotenuse.
Okay?
Yep.
All right, here we go. So let's look at some more.
Let's look at some examples. Now, here's one that's backwards from that last example. Instead of them giving us one of the legs, they gave us a hypotenuse. Now, fortunately, this is one of the easier ones that are like this, because at least the hypotenuse has a radical 2 in it. So if the rule on the last example was that whatever the leg is, you multiply by radical 2 to get the hypotenuse, we're going backwards. So we're going to divide that by radical 2. Well, if you divide 7 radical 2 by radical 2, the radical 2's are going to cancel, and you're going to end up with 7. And so, again, it's the two legs, and then whatever that is, multiplied by radical 2 to get the hypotenuse. Going backwards, you're going to divide by radical 2. So that side ends up being 7. If that leg is 7, the other leg has to be 7 because it's an isosceles triangle. And so x is 7, y is 7. And that was the question. Find x and y.
One of the things that I'm pretty big on, Mr. Scritchfield, when I teach this is that, initially, guys, you should always do like the PowerPoint did there and put your two sides as A, or two legs as A, and then put that hypotenuse as A root 2, because then it kind of makes it a little bit easier to see, okay, what's the difference between 7 root 2 and A root 2, and you just see, oh, 7's got to be A, and so now all I got to do is put the 7 on each side. So, I mean, as you're learning this, guys, it's going to make things a lot easier to go, leg 1 is A, leg 2 is A, and then the hypotenuse is A root 2, and just till you get the hang of this and you can recognize it every time.
Yeah. Yeah, until you get some more practice in doing the operations here. So another example, again, kind of like the example on the last slide, we're given the two legs, but this time they just happen to have a radical in them. Rules don't change just because the numbers get more complicated. So whatever the leg is, you multiply by radical 2 to get the hypotenuse. And so again, the two legs are the A's, and then the hypotenuse, whatever that A is, you multiply by radical 2. Now you got to remember how to multiply radicals. Remember, to multiply radicals, you just multiply what's underneath the radical. And so radical 3 times radical 2 is just radical 6. So that ends up being a radical 6 for that hypotenuse there. Okay? This example is, they give us the hypotenuse in this one. And so the only problem with this one compared to the first example on this slide is the hypotenuse now does not have a radical 2 in it. So that does make this a little bit more complicated. In fact, this is as complicated as these get.
Yeah, I'd say it's one of the more complicated things we've done up to this point this year.
Yeah.
You know, I mean,
Yeah.
because this is a concept that eluded a lot of you guys in Algebra 1.
Yeah, you worked with radicals in Algebra 1, but you got to remember how to do that. And so, again, just because the numbers get complicated, though, not that 10 is complicated, but in this process it gets a little more complicated, doesn't change the rules. So again, the two legs are A and A. The hypotenuse is A radical 2. Well, it's kind of hard to see what A would be in this case because there is no radical 2 behind the 10 or anything. So again, the rule is that if you have the hypotenuse trying to go back to a leg, you divide by radical 2. So if we end up with Z, 10 would equal the A radical 2 there, right? The A radical 2 both and the 10 both represent the hypotenuse. So 10 is A radical 2. And so to solve that algebraic equation, you would divide both sides by radical 2. Or again, if you have the hypotenuse, to get back to the leg, you divide by radical 2. So we're going to get 10 over radical 2. Well, you got to remember the rules of radicals. We can't leave a number like that. It's like leaving a fraction unreduced or whatever. We have to get rid of that radical. You can't leave a radical in the denominator of a fraction.
I always tell my kids it's like building a house on quicksand because you don't know what root 2 really is.
Right, right. It's going to sink in.
Yeah.
So you got to remember how to do that. And the way you do that is called rationalizing the denominator. To rationalize the denominator, you have to multiply top and bottom, numerator and denominator, by that radical 2. Okay, so we're going to multiply top and bottom by radical 2. On top, you get 10 radical 2. There's nothing that's going to change there. On the bottom, you get radical 2 times radical 2, which is radical 4, like we did in the last example. But radical 4, the square root of 4, is 2. So it's 10 radical 2 over 2. However, that reduces now, not the 2's. Do not cancel those 2's. One of them is a radical 2, one of them is a 2. But the 2 and the 10 reduce. 2 goes into 10 5 times, and so this reduces to 5 radical 2 for that Z. And again, because this is a isosceles triangle, if that one's 5 radical 2, the other one's 5 radical 2 as well. So you're going to have lots of practice with this, the whole rationalizing the denominator thing there, but you got to remember that from Algebra 1.
And there is a pattern to this, guys, that you can start to look into, and you'll
true.
see something
Yeah.
that's going to work out. I'm not going to tell you what it is because, you know, it would be more enlightening for you to figure it out. But as we progress for these,
Yeah.
look for a pattern that takes place on almost every single one of those types there, that last one we just did, because there is a definite pattern that some of you may pick out.
Right,
And
which is a definite shortcut.
Definitely.
Yeah, way faster.
Yeah,
So-
you just got to be careful on a certain instance, and that's why I don't want to tell you what it is, because
Yeah.
you'll overgeneralize.
Yeah, yeah, you figure it out. It'll be good.
Yeah, so
Yeah.
figure it out. I mean, and like I said, we're going to practice this in class, so if you're looking at this going, oh my God, I don't remember how to do radicals, don't worry, we will practice.
We'll get it.
Yeah,
Yeah.
we'll practice.
Yep.
Okay?